Okay, good evening and welcome officially to today's class. We are done with the major foundation that we are trying to lay. I think as a master builder, we built well on this foundation under which you can thrive um, networking. So just give me a minute, please. Okay, thank you. All right, I think a good number of joining. So this is a major important topic in our journey, and I'm so excited about it. Not because of any other thing, because it has been a journey so far. And if not for anything, I think we have built the foundation, and we built it like a master builder. Together, we all build this foundation under which everyone will thrive in order to broaden their learning and do more things than what we are currently doing. So it's more like as a toddler, we are all shown how to walk, but some other things that we are able to learn in the course of our journey from our environment and from any person we met in our journey was also helping to guide us. So the same way as we have laid the foundation, there are many concepts that you now know and you are aware of, and you won't be confused, and it will guide you through the course of your journey. When we are talking about things to protect, when they say networks, you already know the area the things are delving into. When somebody said I'm a network security specialist, somebody will tell you I'm a cloud security specialist. You already know what they are just protecting an aspect. So somebody will tell you I'm a system engineer. You already know what they are delving into. So all those things are part of what we are saying. But today we want to talk about an important topic of operating system. The last time we played the game, and I did enjoy the outcome of the game, and I did enjoy it. Whether you joined in or not, you are still part of. You made it fun, and I can see how much you have grown from the point that you started this in September. So today is operating systems. Why am I so interested in this topic? Because every system that we see, whether your watch, whether your what is it called, whether any device that you are using, so far as it can be able to do one thing or the other, and you can see an output, you giving an input, you see an output, you wear your watch, and all of a sudden your watch starts ringing or bringing in messages. All those kind of things, they happen because there is something making it possible. There is something that is putting all those things and making all those functions to be able to execute. So when you click on something and see the output, that is simply the hood, making everything to work. Whether your phone, your laptop, your demo starts, or whatever your car, they are all functions of operating system. They are running because there is something engineering the whole process, bringing in every physics that matters together and making them work. So that's what I'm saying that we are doing today, and we all have to be paying attention as we go through this course of the journey. Okay, so what is operating systems? As you already know, it is the backbone. When we talk about backbone, we mean it is a compulsory software that runs all the intricacies and internal workings of a system in order to be able to make those things do what the user want them to do. So they kind of manage everything. Whether a system was built, they manage all the things that are connected to that system, all the things that make up those systems, those things that make it to work, those things that make it to relate in such a way that they relate and be able to do those things that you see them do, is because there is an operating what system. And the one that we are often used to is Windows operating system. That doesn't mean that's the only operating system we have. We have as much operating system as you can think of. Even the one that is making your watch to work also has an operating system. The ones on a calculator has an operating system. Every of these things we are working because there is something making them to work. There is something bringing in all the whole pieces together and helping them to achieve their aim. So when something assembles everything in a particular system and enables them to work together in order to be able to bring out a particular or an expected result, we say that that thing or the thing which holds these things together is the operating system, the means through which a function can be what done. So when we talk about other operating system, you also know that there are reasons why there are varieties of operating system. There are reasons why there is varieties of operating systems. Why is that so? Is so because every operating system was created for a particular purpose. Why is Windows created? Because there was a need whereby users cannot be able to use a command line. How many of you experience MS-DOS? How many of you experience MS-DOS? How many of you experience MS-DOS? That's the command line that you currently use in your system. It was MS-DOS before. So it only enables people to just type in, and you have to know a command line in order to be able to work with a system. But whereby you that's how Windows came to be. Windows wanted to ease off the stress whereby users, early computer users, or people who are trying to do one thing or the other, don't have to struggle with it. But with a simple click and drag, typing, and other things, they can be able to do what they want to do. So with a click and drag, which is normally referred as GUI, graphical user interface, they can be able to establish what they want to do. macOS came into the view is kind of user friendly, offering the abilities of both the command line and the graphical user interface. So if you are using macOS, you can see you have the ability to use GUI interface. That is the one that is user friendly, and then use the command line if you are accustomed to it and be able to achieve what you want to do. So also we have so many other ones, Linux, purely command line, and Chrome OS, Android, the one that runs and powers our system. So every of these things are what makes our systems work. All these types of or instances of operating system. Then the concern comes, why are we interested in operating system? Because since something makes our systems work, if this is what makes our systems work, if this is what enables us to key in command, get in command, stores transmit our data. So the special focus has to do with is a concern to us. Why? Because there are potential threats that can be likened to them, either when those systems are not updated or when those systems phase out and we didn't try to change them or upgrade to a better version of them. So we are posed with security issues. And also when those systems actually by the people who manufactured them are not able to be or known about things that are wrong, vulnerabilities that exist in them, when we also use it, those vulnerabilities also what back and opening in our systems, in our networks, or as a way to compromise our data. So that's a little bit of what we are trying to discuss today. So let's move on to the next thing. If you are still with me, can I get a thumbs up? If not, can I get your hands raised up to express your concern? Okay, right. Thank you very much. So we move forward. All right. What are these common operating systems? What are these common operating systems? I've even kind of explained what most of them we are doing. All right. We have the common ones as Windows and Mac OS. Windows and Mac OS. Why do I have to bring these two together? Because one of them is closed source. Well, I've already explained the concept of closed source. That means a particular company manufactured an operating systems and they didn't make the uh, code. That means the way in which they manufactured the system open to the public. So it is kind of hidden from the public. They are the only ones that have access to make changes to that kind of system. That is when we say something is closed, is a closed source. Then why macOS is a partially open source in the sense that macOS took its thing from an open source system. So it has the abilities of the things that you could do that is open source and the things that are what closed source. So you don't even have access to change some certain things when it comes to macOS, but there are some certain things you can change in order to make your system work better. So, but in Windows, you can't do anything based on the core infrastructure. You can't change anything pertaining to that. Let me give an instance. What's the perfect instance I want to draw up here? All right, so us, most of us that use our particular systems, most of us that do particular systems, there are things that you change in your phone. Your phone. There are things you can change. You can change some certain settings. You can choose your certain things and every other thing. You can be able to do those things, and then that thing can, in a way, change how the system does one or two things. That is because those part of the things are open up to you to do them. But there are also those things that you can't be able to change in your phone because they are the core things the manufacturers have to put in place. And anything that you change there will truncate the way that system behaves. That's the simplest way I wanted to talk about something to be partially open source. Whereby I'm not saying that this, I'm just using it to explain a concept. So there are things that are you can change in a core infrastructure of the Mac OS in order to make it a better one. Maybe due to you are trying to do a security and that kind of thing. So there are permissions you can be able to change and your system will behave in a different way. But when it comes to Windows, you can't change the core infrastructure software of Windows at all. So, but Mac OS, you can change some, and there are some that you can never be able to change because once you do, it affects the overall performance of that system. So another interesting one of those things is the Linux, which most of you will be using oftentimes because you are a security analyst or a security operation person. So you are, that is the operating system that is dedicated purely for cybersecurity because first of all, when the web was built, it was built in as kind of things of textual form of things. This graphic they are seeing here is more of beauties, is CSS and presentation layer that are doing all those things. Before the web is just something you'll just be seeing textual things. How many of you watch films? When you watch film, you start seeing a long text scrolling on somebody's screen, and it is just black and white. That was how system was developed. So that is the for you to know how to control a system, we have to go back to the where how these systems started off before we started seeing all these things that enables us to do one thing or the other without stressing ourselves. So we have to go back to the back, and that is what Linux does for us. It's purely on, well, command line, let's say. That's what makes it work. And they have different distributions. When I say distribution of Linux, I'm saying various things that were made out of Linux. When we talk about something was made out of something, we are saying that the core thing that makes Linux what it is didn't change. But there were something else that was done or added on an additions in order to create a specific another kind of operating system out from Linux, and those things are what we call distributions of Linux. They came out from what? Linux. So the same way most of you came out from somewhere, and then you didn't exist in isolation. Your parents, you are the offspring of your parents. So the same thing we can say about Linux distribution, that they are the offspring from what? Linux. So in order to serve a specific people, they were created out from what? Linux. Maybe they will say for enterprise network security, we want to create a special kind of Linux operating system, and we'll name it this so that it will be able to help secure enterprise form of connection. So that
Connection.
is how we
That
is
is
Linux.
Linux.
So
So
that's what we say is Linux distributions. So that being said, what is Chrome OS? I think many of you might not have used Chrome OS, but Chrome OS is that's a Google form of operating system that runs in most of their you see all these their tablets, Google tablet, Google produces tablets, and some of their devices. Then most of their home used products, so they run based on this Chrome OS because it's actually for user. All these tablets that you see are part for education purposes that you often see run on Chrome OS. And because it is partially open source, in the sense that when I say something was partially open source, it was the very core infrastructure that was used in the development or where it took its roots was first of all an open source, and somebody used an open source and created something and then decided to start marketing that thing as their own. So many of you too, the same way that there are things that you didn't develop from scratch, but you use what was developed in order to build an advanced form of something. So that is regarding what these things, when we say something is partially open or source. So they are part of the thing that were open source, and they are part that were something that was integrated or increased or done extra in order to what? In order to make more functions out of what is already existing. So that's about Chrome OS. So we also have the ones that are mobile, like your Android, iOS, also those ones are mobile. Many of you also use Symbian iOS. That's to also bring your knowledge that that's still a part of operating system. Our Android is open source. It was created as an open source. There can be modification you can do to your Android. There are modification. Many of you that might not know. There are modification you can do to your Android device. There are so many modifications you can do so to it because it is an open source thing. Somebody can contribute to it, and somebody can change some certain key configurations in order to make their device behave in another way. iOS is partially open source, so there are some core infrastructures you cannot change, and there are others that you cannot change. You don't know what is Symbian iOS? Sorry, I'm sorry. Somebody asked the question. There was this phone that we used then when Nokia Touch came out. I think that was Nokia phones came out. There is this kind of Java phones. They call them Java phones. And people we are using it to play this kind of advanced games like football, but they are still button phones. And they will tell you that this is Symbian phone. They will say it's a Symbian phones then. So they were using iOS, a different kind of, it wasn't using anything close to what we talk about Android. Before Android started coming out, those operating systems were there and they are working. They are still even invoked till now. Even iOS, people in, how many of you are using, what is it called? Windows, your Windows phone, many of you that are using Windows phone, you use Windows OS now, right? There is a special Windows OS for your phones. Many of you that are using Apple, what do you think you are using Apple? What do you think operating system does Apple use? What operating system does Apple use? Those that are using iPhone here. Okay, they have answered. Those that are using iPhone, they have answered me. All right, so thank God that you really know it. So that's all on the common operating systems. So is there any concerns? Is there anything? If there is none, can I get a thumbs up? If so, somebody can raise up their hands and ask their question. All right, thank you. All right, then I still want to talk about vulnerabilities, because I have already said that since these operating systems we are manufactured or we are created by humans, especially everything that is meant by humans will still have a likely weakness. Yeah, that's the truth. Everything that was made by a human has a, there is nothing that is 100% secure. So even if those operating systems are powering your system, the fact it was made by a human, even the aircraft that we take, the buses that we balance, that there are things that run those buses, and the other thing that we place our trust in, all those things that we place our trust in, we enter a car, we enter everything, they all have weaknesses. Anything is bound to happen. So since they have weaknesses and open holes, so what can we do to guide against them? So if we know that a car has a thing, a weakness, right? What do we do to guide that car, just in case the day that those weaknesses showcase or those vulnerabilities or are bound to what are bound to be noticed? What should we do? That's where the problem comes in. So as you enter an aircraft, that's an aeroplane, what we are talking about, once if something goes wrong, there is what we call a parachute. So you have a parachute to do what? For us to do what? Escape through those vulnerabilities that would just bound to what happen. It will always happen. They are bound, anything can happen. So since that thing exists, the same also applies to the operating system that we have. So since this operating system exists, they have vulnerabilities that we talk about. The first of it, or most to start with, is legacy operating system. These are the kind of operating system that there is no current development happening on those operating systems. The manufacturer, the developers have ceased to currently update them. They are no longer concerned with regards to them. So there are many apps that you are using on your phone since 2012 was the last update. If you go to your Play Store, you will know when an app was last updated. Like if you go to a Play Store about a particular app, you read through, you will see when the last update was done. If you are using an app that the last update was done 2022, just imagine from 2022 to 2024, what likely thing would have? Just imagine your bank, they don't update their applications and you still use it since 2012. You are bound to lose money, you are bound to enter a trap of an attacker. So any app that you are using that doesn't kind of have, it has been long that my developer have stopped issuing out updates, then you are bound to risk. That's one thing about that. So it's supposed to be a current development. So they are called legacy operating system. So they don't receive any further updates. They are vulnerable to threats since it has been lost, updates have been done to them. So those are the first type of vulnerabilities that are associated with operating systems. Then the second one is systems that are currently in use, but we as persons don't update them. We don't update them. So those are also systems that are not up to date. So every operating system that update that comes to you and you don't do it is kind of trying to also showcase a common security word threats. It showcases vulnerabilities and the threats that are likely to follow through with them. So these are mostly the things that we see when we talk about operating systems and vulnerabilities. Either that operating system have stopped receiving updates, or you as a person decided not to update those systems. Meanwhile, apart from this, also there is no system that is 100% operating system that is 100%. There's also things that you put in place, because those who manufacture that operating system, why they are still releasing updates is because they are discovering every now and then there is something wrong with their system and it needs to be fixed. So you too don't rely heavily on the operating system updating for you to secure your own part of the deal. So there are also things that will enable you to strengthen your effort besides using operating system. That is why we have what? That is why you have what? Antivirus. That's why you have defender softwares. That's why you have firewalls. That's why you put those things in place, just in case a particular operating system has vulnerabilities, you can still withstand against any form of threat. So how can we be able to track vulnerabilities that exist in an operating system? Some of the tools that you use or you see are Microsoft Security Response and CVES. CVES is a database that have a compendium of issues that are related to operating systems and the vulnerabilities associated with them. Please find out the full meaning of that. It has to something to do with vulnerabilities, exposures. V is vulnerability, exposure. C is something. Just find out the meaning, please. You see, I know the meaning, but I know what it means, but I can't remember what they see really mean. So please, anything that you just know it, just in case somebody use the full meaning. If somebody use the full meaning, I will know. So anything I use an acronym, please do where to get them and know them. Then we have the Google Cloud Security Bulletins that have a compendium of Google's vulnerabilities that are existing in Google. So why are these things open? Why are they common vulnerability exposures? Thank you. Why are these things open to you? It's so as to tell you that operating system is not a kind of thing that is secured. You have to also bring in your own security aspect of it, aside from what the developer is doing on their end. So Google will tell you through their Google Cloud Security Bulletin what vulnerabilities that are still existing in their softwares or in the systems or that runs whatever that they do on their devices. So Microsoft also released their own through Microsoft Security Response, and CAVES is kind of a database that have common vulnerabilities of various kind of systems and what they can likely face when it comes to threats. So those are the there are many more of them for us to track and know what we have to protect against when it comes to using a particular operating system. Are you all with me? If that's so, can I get a thumbs up? If not, can I get a consign? All right. Okay. So can we talk about where OS comes in a computer system operations? Where does OS come in? Where does OS start to take its role from? What is their work? Where does it start functioning? So once you have clicked the booting aspect of your system, you have on your system and press the boot button. The first thing that happens is what we call BIOS stroke UEF. That's the booting process start. What is BIOS? Basic input and output what? System start. So it start looking at and checking in what is in your system. Is there any mouse connected to your system? Is your RAM in your system? Is your storage device in your system? Start checking the essential component that the system needs. So those are what the BIOS to UEF. For old systems, they still use BIOS. For new systems, they still use UEFI. Then sometimes a combination of both. So that's how it's better called. Then once that thing is done, basic input and output system is checked, everything, then it goes to the bootloader. The bootloader now activates the what? Activates the OS. So that's once the OS loads. So OS takes up from where the booting process, everything has been checked off. That is when the OS says. So if everything has been checked, if everything has been checked and the OS didn't load, that is to show there is a problem because the BIOS have done its work. The bootloader that are supposed to activate the OS is having issues. Nothing will be able to work on your system. Your system stops there because it's your OS that directs your system further on where to get all your files, where to get all the things that they need to start up. We have to get the photos that display when you say Windows, you can now sign in. We have to get the actual login details. So it's the OS that does that thing. So the booting aspect, once the hardware has done their part, that is the input output has been checked. The bootloader, which drives all the booting process, have to activate the OS in order to finish loading up everything. So if it doesn't, that means there is an issue. So some of you that have issues that your computer just starts, but it doesn't show anything. So invariably, we are probably will be looking at the OS. So once this OS starts its thing and it's loaded, we log in and do everything. For any person that wants to complete a task, they have to also utilize this word OS. How does it really come into be? You as a user, you will probably use an application to achieve any aim that you want to. So when you put in an application, you send in a command, the OS takes it from there. It is the OS that will tell the hardware, this is what you have to do based on what I receive from the user. So the OS is the interface between the hardware and the application and user. So without the OS, there cannot be order in the system. So OS is the run around, is the man in charge, as we often say, the man in charge, the person who does the decision, the person who makes the decision. So if the OS is hanging, everything in the system will hang. But if an application is hanging, your OS can be able to what? Halt that application. That's why you can be able to say close this application and your OS will do so because your OS is working. But if your OS hangs, everything in your system, you cannot be able to do anything. Press your mouse, press to your OS resumes for duty. So this is the role, the user to the application to the operating system, to the hardware, goes back to the hardware to the operating system to the application, and application to the user. So this is how the functioning or the involvement of the OS in the computer systems operation. Are you all with me? If that's so, can I get a thumbs up? If not, can I see you express your concern so we can move forward? All right. Thank you. All right, Victoria.
Good evening.
Good evening.
Please, I didn't really get the booting process.
All right, I'm just kind of trying to say the involvement of where OS starts its duty. Once you press your on buttons, there is what we call basic input and output system. It starts to check everything that is your system, your RAM, your storage, your everything that is connected to your system that is needed in order to carry out one thing or the other. So it is kind of checks them and registers them that these things are available. Once it does, it moves over to the bootloader trying to load the OS because it doesn't know nothing else can display your system unless what makes that system to work. So once those things have been identified is present, all the necessary hardwares are present. So the OS, which is the software that runs the whole entire system, will have to be loaded. That means it has to what? Be activated. So once it is activated, so the OS will do every other thing required. It will bring in your files, it will bring in your login details, especially those of you that have password. It will know the one that is the right password. And so it is the operating system that takes up immediately the BIOS, UIEFI, that's from BIOS is done. I don't know if you get that now, Victoria.
Yes, I did. Thank you.
All right, so let's proceed. Okay. So let's show an example. Let's assume that you want to download a file from the internet. Let's use it as an example to explain that operation. You as a user, you will use an application called a browser, right? When you enter into your browser, you say download the one that I was trying to show you the other day, 5 a.m. Club by Robin Sharma. So that's a good book though for people who are interested to know how to be disciplined and consistent with their daily life. All right, so for instance, the people that want to download maybe a different versions of a book, a scripture, or whatever. So once you are able to do that, you enter into your web browser, which is an application. What that web application does at that point is to communicate, which is the browser, to the OS. The OS now does what? The OS now do a request and interacts with the hardware, telling it that this is what this person wants to do. Do it. So it will now be ready. The storage device will be ready to receive that file. This thing counter that shows the file have started downloading will be ready. All the things that enable the input things that bring in documents into a system, our hardware components are already ready. So once the hardware have received this and done it, it sends back an information to the OS. See, I've done what you said I should do. And the OS sends back an information to the browser. That's now when you now see an update. This file has been downloaded and it is in your device or storage. So that's it, invariably what I'm trying to say. So the operation goes this way. So it goes from the user to the application, from the application to the operating system, from the operating system to the hardware. So without an operating system, nothing will be able to run in your system. There will be statelessness, disorder. So it is the operating system that brings order and oversees the activities of every other thing in a particular system. If you understood this, can we get a thumbs up? If not, can we move over to all right, so you're always free to raise up your hand if you are confused about anything. So, as I said, it's not just alone for you to talk about having these operating systems resident in your systems. Like it must be your local system. Like many of you who are using laptop, you have Windows or you have Ubuntu in your system. So I've already told you something on virtual machines, ability to run an operating system or run a particular system in a separate environment. That kind of environment is what will enable you to do any form of testing that you want to do. So let's assume you have not installed Windows 10 in your system. If you want to know how Windows 10 function, you can be able to deploy a virtual machine and install Windows 10. For anything you are able to notice in Windows 10 in that virtual machine, given in that you put in the requirement for your system, like you check the RAM, you maybe assign it, your system is using 4 GB, you assign 4 GB. You check your storage, your system is using 128, you assign it. So those things that are necessary in your system that are key requirements, you put them in the VM and started it. So the same way the thing will show that it is running in a virtual machine is the same way it will also work mostly if you also install it in your system. So if you are not so sure about an application that you want to bring into your systems, like your corporate network of your organization, first of all, try that application somewhere else. Try out everything pertaining you want to try out. Maybe how they store their password or how they are able to everything, whether it is HTTP or HTTPS, whether they use. So try out everything on a virtual machine before you kind of bring it in. So this OS can also run in a virtual machine. So and perhaps enables us to do various testing before we can actually deploy it in the main systems or the main environment in which you want to do it. So what's the benefit of running these operating systems or bringing in these softwares into a VMs? Is because of from the security standpoint, we can be able to learn more about them and then be able to stop any form of thing that we feel like is posing a threat or kind of bringing security to the base of it. A minute, please. So, as I was saying, from the security standpoint, if we are not so sure about something, what we first of all do, we have to test it out. It enables us to know how these things work. Rufiat, you are raising up your hand. Any issue?
Either you take the weight, the non-bread.
I didn't hear you. Okay, so um, and then it is kind of efficient. Why? Because we don't need to burden ourselves to what? We don't have to burden ourselves to buy different computers and install operating system is on. So you can have one computer, and with that one computer, as a cybersecurity specialist, you can run multiple OS because there is what virtual machine. So each virtual machine will have one operating system running on them. So each virtual. So as you are using your Windows, you don't need to scrap your Windows. You just need to use Hypervisor 2 and then be able to deploy a virtual machine that enables you to run various type of operating system. So that's what Hypervisor will do for you. Hypervisor is what enables VMs to run. It allocates storage, allocates different resources a VM needs in order to run perfectly well. So there is Hypervisor 1 and there is Hypervisor 2. Hypervisor 1 is the one that enables you to run virtual machine on a bare machine, whereby you can be able to, once on your login, you will now be able to choose the operating system that you want to work with. Immediately your system does BIOS, it will ask you which operating system do you want to use. That's Hypervisor 1. So you now choose and it will load that particular operating system. But the one that has to do with Hypervisor 2, you have to use an operating system on top of the already host operating system you are using. That means as I'm using Windows now, I can install an operating system with the use of an application called VirtualBox that makes provisions for having other operating systems. So whichever case it might be, hypervisor plays the role of making it possible for us to what? For us to run operating systems in our system. So that being said, are you okay with that? If that's so, can I get a thumbs up? Okay, Rafiat. Rafiat, you can speak now. Rafiat and Praise. Who is speaking? You can open up your mic.
Hello. Good evening.
Good
Yeah.
evening.
I just want to ask about this unboxing. What is unboxing? What's it about?
What was?
Sandboxing under the security. Provide an isolated environment.
Underwords.
Sandboxing. Benefits of using VM. There's something about sandbox.
All right. Yes. The same thing. See, the same thing that what is it called again? Sandboxing is also a security principle that I said. The same, they almost it follows the same principles like virtual box, sandbox environment. It's a kind of, but majorly sandbox environment have to do with cloud-based systems. I get what I'm saying. So you just take something elsewhere outside of the normal environment is meant to do. So for instance, if I don't like to deploy virtual boxes in a particular system I am in, I get me, I can try the cloud and then buy some space, deploy an operating system, and see what it looks like in the cloud. So that's more like taking something outside of my normal environment in order to be able to test out something and see if it's safe or not. Analyze the operations of that thing. So that's what simply what sandboxing is. So a kind of thing I want to give you now almost is when people before people deploy applications, they first of all test out that application in a standard in this like this thing is meant to run in this environment, but you don't want it to run here for now. You take it to another environment and see what it looks like. Why by that environment you are taking it to still have the same physical features, abilities of that other device. So you kind of replicate a new environment, which is an isolated kind of environment, which is a virtual environment, and then you can be able to do those things there, and then be able to revert back once those uh, once those operations have been concluded. Having learned so much about what can be obtainable there. So that's invariably what sandboxing is. I don't know if I explained that to you very well.
Sir, please don't be angry. Rafiat's microphone is on, so I could not really hear what you were saying.
My what?
Rafia's microphone.
All right. So when
Huh?
we say people say they are sandboxing something, sandboxing is just more of the same concept of has likely similar the same concept of virtual machines. So, but this time around, we are not trying to see to the need of most times when we talk about sandboxing environment, it is more like cloud-based systems that use sandboxing environment. All right. So, but the concept of sandboxing have to do with if I know this application, I want to install an application. I'm giving an instance. You want to install application in your system. You don't know how these systems behave. You don't know anything about what this application is all about. You can't risk it to just put in an application in this. So I can be able to just say, okay, that's what we call cloud services. So I can be able to rent a particular cloud services, yes, as the name implies, and say, okay, since I want to try this app, I don't know what it looks like, but let me see what it will look like when I'm able to choose the RAM. You now choose the RAM, like you now look at your system and say, okay, my system is 4 GB RAM. Okay, you put 4 GB RAM in the environment that is being talked about. Then your system uses a storage device of 128. You put in 128. Your system uses this and this. Everything that is in place I will put it in that environment. So what I'm doing is taking outside of the sketch of where I want to utilize that particular application. I don't want to test it out. I don't want to use a production environment to test out something. So I want to test it out somewhere else and before bringing it into my main environment. So how can I more explain this is this way? Is this way. For instance, there is something in your home, like you want to try out something in your home. All right, you want to do what? You want to try out, okay, let me say you want to change a bulb, a particular bulb in your house. You go to a person that buys it, right? And the person will be like, okay, this is the bulb that you want to buy. You have told the person. But for the instance, you don't even know what that bulb look like. You have heard about that bulb. You have known about that bulb and you want to know what it looks like. And that person have a mechanism to put in that bulb somewhere and see the effect. You are seeing the effect. But that effect is not created in your main environment. You are seeing that effect in another environment. You are seeing how that bulb behave in another environment. So it's not where you are using it properly. So you are saying to yourself now, since this bulb is looking wow in this place, that means when I bring it to my home, it's going to. So sandboxing is a kind of system that takes out something that should work in our current environment, this similar environment like the one we want to use it. And once it's done, knowing what that thing could be able to do, the potentials of those things, both the advantages pertaining to it, then it can now, we cannot take it and deploy it in our main environment. That is simply what sandboxing is. Are you clear on that?
Yes, sir. Thank you, sir.
So was Rufiat, are you clear on that? Stephanie and Rufiat are still raising up their hand.
Yes, please. I would like you to like better explain the
Yes,
type of
thank you.
hypervisor.
Okay, hypervisor is simply, all right, let me look at something that will suit well with you. Okay, all right, okay. So hypervisor can be more of trying to, all right, let's say you want to do something, huh? You don't know, you don't know how to do this thing, and you don't even know what it takes to do this thing. So hypervisor is more of something or a I'm looking for a better way to. All right, so take it this way. What enables you to be able to put in all the resources that you will have, you need in order to do some certain things is what a hypervisor will do for you. So hypervisor will do for you, help you to set the storage, help you to set the network, help you to set the database, help you to set all those things that needs to be in place for your operating system to work. That is what hypervisor does for you. So it helps, not just help in putting them in place, it also help manages it. So it knows that there will be a RAM that will be needed in order for this operating system to function. There will be a storage capacity of about so and so in order for this operating system to function. There will be a network connected so that this system can function efficiently, especially when it comes to browsing the internet. So hypervisor is what takes care about the underlying thing of network storage and computing power. These are the things that is necessary. There are other things, but you see storage, computing power, and network, it puts them in place because that is how the operating system can be able to be deployed and function better. So I'm not trying to tell you that this hypervisor can work in two ways. If I'm trying to install virtual machines on a bare metal, that means like this way your systems are, there is no operating system installed on it. So you want multiple kind of operating system to run on it. So I will need a hypervisor one form of hypervisor one to do that thing. What is it going to do for me? Hypervisor one will place the requirement for me to be able to run two operating systems or three in my in my bare metal, which is my system. When I call bare metal, I know it's my system. So once it does, what it will now say, since this system is using 16 GB, so okay, let me give this Windows 4 GB. Let me give this Linux 4 GB. Let me give this one 4 GB. That's 12 GB. And let me hold on to 4 GB just in case. So though it has properly put in place everything pertaining to network, computing, storage capacities that will be needed to run. So that's hypervisor 1. So when you are trying to log in, you have to select the particular operating system you want to use. So unlike this one, if your system wants to run, it automatically select Windows, because that's Windows is installing it. When you use Hypervisor 1, it enables you to install more or as many as operating systems, depending on what your capacity of your hardware requirements would look like. So that is Hypervisor 1. Hypervisor 2 is allowing you to have a host operating. There has to be a currently running operating system through which all your system activities will be based on. And on that operating system, other operating system can still function. That means as this way I'm using Windows, I can be able to install Linux, I install other things, and yet it doesn't affect all the activities I'll be doing on my host operating system. And everything I do in those virtual machines still remains there, and they don't have anything to watch. They don't bring in any document, any threat that is located in that virtual machine will still remain there. So what enables these things to run concurrently, that my host operating system functions and activities doesn't disrupt the other operating system in my existing as VMs, is because there is hypervisor 2. So whichever case, these are the true hypervisors, and their rules is simply to manage and allocate all the resources that will be needed to keep the operating system running. Is that clear now?
Yes, sir, it is. Thank you so very much.
So if we are on the same page, can I get a thumbs up so that we can continue? All right, thank you very much. So thank you very much. All right, this is what I kind of a depiction of what I was trying to say. You can see a physical machine using virtual machine, 3 virtual machines, and all these things are doing different things, and their things are not related. What I do in this VM, what I do in this VM will not happen in this VM. What I do in this VM will not translate back to this VM. So the abilities of a VM is they exist like independently of themselves. That is what it's like, independently of themselves, functioning like a complete machine, but they are all utilizing one physical resources. And we can be able to do kind of different things with one and the other. So is that one clear to you now? So let's move forward. Thank you. So when we talk about user interface of an operating system, it can exist in 2 ways. We have the CLI, we have the GUI. CLI is command line interface, and the GUI is graphical user interface. So any of the operating system we'll be using during the course of our journey will either be GUI or CLI. CLI is simply ability of knowing command and then doing test-based kind of support, while GUI has to do with more of click and drag and graphics, user friendly nature. So you almost at times would come across a system like Ubuntu. I think if you are using Ubuntu, you know you have ability to use command line and ability to use GUI. So that's the beauty of it. So whichever case it might be, the only advantage I would love to tell you all is that with a CLI, you are more powerful than somebody who is using GUI, because the core infrastructures that we run, we know them as commands. We don't know them as GUI activity. That means graphical user interactions. So you often do more things than a person that is using a GUI. And one other things about CLI is that what is it called? It keeps track of every activities. It keeps a logs of every activity you are entering in the command line. You can be able to go back to so many things that happen, or the things that so if you invariably make mistake during your issuing command, you can easily revert them back, because you can know what from your history files what you did that went wrong and where you started getting it. So you can read on previous command as late as possible from the starting of this year to now. You can still read on them with the ability of CLI, but you will not likely have the same scenario when it comes to GUI. So that is one thing that you have to. And then GUI is restricted. You have to do one thing or the other. But with CLI, I can do multiple things at the same time. I can open different things and I will do them the same time. So I can run 3 commands and they'll be running. Those things will be displayed on my system immediately. This one. So you are restricted from such activities from GUI because you have to do one thing or the other at a time. So that is about that with regards to CLI and GUI. And during the course of this, your journey, you will often be using CLI. You have to know the command line interface. So are you all with me on this? If that's so, can I get a thumbs up? If not, can somebody raise up their hands and case they are concerned? All right, thank you. So this is a graphical image of what that looks like. This is a GUI. You can see you are seeing graphics. We click on messaging. But if you want to send messaging in CLI, you have to type it in. You have to type out everything. So this is sort of login. How we log in. Login sessions.txt. We now see all the files. But here, you have to now click and they say enter. But there you enter it yourself. Login, this, and this, username, password. You enter those commands with a command line. So that is the beauty of what we are trying to learn. Are you all with me on this? If that's so, can I get a thumbs up? If that's not, can I get? So one other thing I want us to be doing is installing VirtualBox and OS. Well, I don't really need to stress you, or this can be a little bit of process, but what I just want to say on this is to install a virtual. Most of you want to run Ubuntu or some other things on your system. Is that you have to download VirtualBox. You have to download VirtualBox. You have to download VirtualBox from virtualbox.org. Please ensure that you select the particular one that works for your system. All right, so if you download a VirtualBox, or should I even be showing this? Yes, I think so. So let me share something else, present something else. Okay. Oh, sorry. All right, so I thought I'll share my screen. All right, so as I said, I'll download the latest version, please. Okay. All right. So this is powerful open source virtualization. Are you seeing that? Are you seeing that? Please, if you are seeing that, can I get a thumbs up? All right, this if you go to virtualbox.org, if you go to Deborah, what's the issue? Deborah, you raised up your hand. So when you go to virtualbox.org, all right, so you see download this. So you download this. So when you click on download, it will bring you to the point of telling you to select the particular package. So for those of you who are using Windows, this is the one that you'll be downloading. For Mac OS, we have Apple, we have Intel. So know the one that your system is. You can choose for Intel host. For Mac OS. For those who are doing Linux, that are on Linux, your host operating system is Windows. Use this. Your current operating system is Windows. Use this. Your current OS is Mac OS. Use Intel. If it's Intel host, you use. So if you are using on Linux, you use. If you are using Solaris, you use. If you are so anyone you are using, please just click on it and download it. So if I click on Windows host, it has started downloading. You can see it here, but I've already downloaded this, so I don't need it. I'll stop it. So that's on that. Once you download it, please run the installation. Just you have to double click on the file and then click on next. Keep on clicking on next to the whole installation is the same way you install application on your Windows operating system. So once you are done with that, there is something you call this. Then this is what opens up to you. Are you seeing this? This is what the Oracle VM VirtualBox manager. There are other virtual boxes, but the one I prefer is Oracle VM. The other ones, yeah, you can still try out, but this is the one I prefer. So once, Stephanie, your hands are raised up.
Yes, sir. How about VMware workstation?
Yes, it's still also okay. If you know how to use it, you can still use it, or you can still browse about. So nobody is an author of all wisdom. That is one thing I want to know. So if in case this one I'm showing you and you felt like there is one more better off than this, you can browse about it, and I'm just like giving you recommendations based on the one that I have come to use over a period of time. So VMware is also part of them. There are also many of them, as I said. VMware is also good, so you can try them out as well. So, but I think the process of deploying operating systems should be the same across them, like likely the same somehow, or you have to read up instruction on how to do that as well. So that's why I say we are all open to learning in case we forget. So you can try it out. Stephanie?
Yes, sir. Yes, sir.
So this is it. So this is it. So most times what it should be is add. So when you click, when you just, and then secondly, you have to download the operating system. You have to download the operating system. But the operating system you are downloading is not the normal one that you used on your host operating system. The operating system that are specifically for virtual machine use. So those are the ones that you are meant to download, either as ISO file or as OVA. ISO is the file type of operating system you'll be downloading. So how do you get that? Normally, I use OVA because OVA from Cisco Academy. That's from Cisco Academy. So I use OVA. When I'm doing this kind of teaching, I use an OVA, and this is how I'm able to do this. So I can still drop the link for you also for those that want to download Kali Linux, but you just need to do something, open an account, or you can still use your normal listing, open an account, then download it. It's a heavy file indeed. But once you get that over file, look at what you ought to do. You just have to click on what? Sorry. You just have to click on add. So when you click on add, because it is an over file, you are just trying to import. So if you don't want to do it that way, where is this? Let me click this. That I'm saying if you are downloading from Cisco Academy, they are over file. So that's the easiest and simplest way. But every other one, like the ISO file, you have to, there's also another way to install it into your virtual box. If you'll be downloading that one, the only thing you need to do is to do what? Click on add, and it will tell you select the file. And once you are done selecting the file, it will start installing the file. So for here, I can go to my desktop. Let me even, where did I even put that file itself? Okay, personal, I think it should be here. No, it's not here, it's not here, it's not here. Sorry, I don't even know where I put that downloaded file. All right. Go this way. So I think we will use this one. Go this way, click on file for the over file, click on import appliance. So it will bring out something like this. Then click here to locate the file. So desktop. Look at the file, the two files. This is Kali Linux, this is Ubuntu. So these are the provisions that Cisco made available for those who have been doing any of their cybersecurity endeavors that will be using Ubuntu, both ethical hackers, things, so learning pathways. So this is what you'll be using. As a cyber ops, they made provisions for this. So they have already done a whole lot of work on this. So when I say overfile, I'm simply saying that Cisco, in their effort, already have some things that they did with regard to this operating system from the security aspect standpoint, so as to enable most of the learners or practitioners of cybersecurity to be able to what to be able to enhance the already development they have done, and then use it to actualize one or two things during the course of their learning. So that is why I chose this. So most of the things I would need to install in due time for my cybersecurity learning, I don't have to install them because most of those things have been taken care of once I already deployed this. So this is also for Kali Linux, this is for Ubuntu. So as I said, let me go back to what I'm saying. If you go to your VM VirtualBox, I told you download VM, download the, if you are going for the overfile of the Cisco, if you download it, when I will drop the link, you just simply have to, but it's a heavy file, as I said, go to file, go to import appliance, then the source is from your local file system. Choose this. I don't know why this thing. Oh, why are you blocking me now? So choose this. Import from this is a file I've already downloaded. So if it's this one, I'll click on it and click on what? Open. So once I click on open, I'll click on what? Next. I will click on what? Finish. So you see this one is easier. Are you seeing that it have started importing appliance? Are you seeing this? It have started importing the appliance. So once it's done, it can now appear here as one of the installation. As you can see, I'm running Ubuntu, I'm running Kali Linux. So, but since I've installed this, I will stop it. Since I've installed this, I will stop it. So once I'm done importing, I will just simply what? Check the one I want to, either Kali Linux or Ubuntu, and I'll click on what? Start. So it will start what? It will start the operating system the same way you also log into your system and Windows starts up. So it will start it up, operating. But to make things easier, I would just love all of you to download the over file using the other method of downloading the ISO file and then trying to do that can be a little tricky and then can be a little kind of thing. Since I don't really have that one here, that's the ISO file. I should have also showed you, but it's kind of easier. It's just that here you will click new or add. So as you can see, my VM is starting. Look at it. My VM have started. It have started. So I can do anything here. I can browse a file here. I can do so many things inside this VM. And those things I do inside the VM won't also impact what I'm doing currently. So if I save a file in this VM, it will remain there. As I said, you can see why I'm recommending you to use this for our learning for the main period, because as a cybersecurity analyst, it has done a lot of work for you here. As a SOC analyst, that is cyber ops. That's what most of you are being trained on. As a security engineer, you have your logins. So it has different logins to utilize for everything that you're doing. And their passwords are here. And most of the things you will be needing have been taken care of. So I will click on login. So let's see what I'm saying on VM. So you can see the interface. You can see it. You can see I have this thing, what is it called? I have graphical user interface. As I told you, Ubuntu have the ability of using GUI and CLI. So look at my GUI. So I can click on the Firefox browser and it will open up a Firefox and we can download a file. And yet that file will not enter my system. So what are we going to try out? Download uh 5 a.m. club. So are you seeing that the same thing that we are trying to do? I'll click on it. So this is happening in my VM. It's not happening in my main system. So I've seen it's 252 pages, right? So I want to download it, and you will see that. So it has opened up. So I'll click on download. So if you ask me where do I want to save it in my VM, I will say desktop. Okay. Click on save. It has finished downloading. So let's go and check my desktop whether it's there. Are you seeing it? Are you seeing it? And I can view it. Let me open. What will I use to open? Is there any PDF here? Or is it still the same without the same firewall? Let me use Firefox. So if you open the file, you can see I cannot read it. This thing that I downloaded, how you will know that it is not in my system is if I go to my downloads, you can see it's not there. It didn't appear. So that means it exists in the firewall browser. So that's about this. This is about the installation. So what else should I? Okay, let me show you the command line too, just in case. So I can simply click on terminal. So this is the command line aspect of it. So I can now start entering command line echo Rufiat. I want it to print Rufiat for me on the screen. So that's it. All about that. Echo Veronica Abi. Okay, so that's about the command line. So that being said, so that's about the installations I wanted to show you on this. So download the VirtualBox, just do import appliance, select the particular operating system that you have downloaded, and it does the whole stuff. When it do, you just click on start and it starts running. You have your environment up to yourself. So that's on that. Are you guys okay? Are we still on the same page? Are we all on the same page? All right. Okay, Bola, you can express
Hello,
yourself.
sir.
Yes. Who is talking? There
Okay,
are
sir.
three
The link
people raising up their hand. Someone is that?
is praise. Is praise.
Yeah, I know. I can hear you.
Hello. Okay. So what I was saying is the link you're going to give to us for the Cisco over file. Is it for will you still give us
Yeah.
for Kali Linux as you're going to give us for Ubuntu? Are you going
Yes.
to give us for Kali Linux?
Yes. All of them will be in the link I will send. I think I should even send it now.
Okay.
Where is it? Net
Do
arcade downloads.
Telegram group too,
Okay, no problem. Okay, so is
sir.
there any other pen that is asking?
Send the link to the Telegram group.
Okay, I will.
Okay. Thank you, sir.
So who else wants to ask a question? I will send that. Rufiat, I think there's also another person.
Good
Okay.
evening.
Good evening.
Good evening. Yes,
Good
I've
evening.
installed the Kali Linux on my phone. I just want to ask if there is need for me to install another one.
No, 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 no. You can do well with. If you have it already, please do well with what you have. It's still the same thing. I'm just trying to show us how to replicate whatever we'll be doing during the course of our practical in your own system as well. So that's it. So you don't need to install
Okay,
any
thank
of
you.
it. So I think Ubuntu or Kali Linux, anyone you want, you can use it. If you want the both of them, you can still use it. It's up to you. You know your system capacity more than I do. So if you can carry the boat, it's still okay. So is there any other
Yes,
person? You can
sir.
raise
Can
down
you
your
hear me,
hand.
sir?
Yes, but I can hear
Okay.
you.
Sir, did you just say that if we already installed Linux, like Kali Linux, we should not install the one you want to send to us? Is that what you're saying?
If you want, it's a choice, but if you have that one that you are using, it can still do so many things we'll be doing the course of our lecture, trying to try out one system command or the other.
Okay, sir. Please, is there like a way we can get a step-to-step way of installing these things on? Like, because after what you just showed us now, I mean, we might not be able to, for me, I don't even not say we, for me, I might not be able to remember all these things you just showed me. So, like, if there's a step-to-step, like, way of installing these things on our system, so we can just follow through. I don't know if you get, will it be on the link or like there's another step-to-step instructions?
There are plenty of as this, but there are plenty of ways to do it. As I said, this is for me trying for those who want to make it easier. This is the easiest way I was showing you. Or if you download that over file, you just have to open your listing, click on import, select the over file, click on next, and everything is on. You can start your VM. But if in case you are going with the ISO file, there is also another way. So, but you can do well with if this any extra thing. That's why I was telling you people how to do research. You can research on YouTube. There are so many things to guide you on installing that. But if it's the one I'm showing now currently, I can still drop the step-by-step instruction. Are you with me?
Yes, sir. Thank you, sir. I appreciate that. Thank you.
All right, no problem. So as I said, it's a heavy file, so you guys should also get a required amount of data for those that will be going with that. Rufiat, you can talk. Okay, Adewara.
Hello, sir. Good evening, sir.
William.
Yeah, yes, sir. Please, I don't really get what we are downloading because the network is bad here. So, like, your voice is breaking. So, what are we downloading and how are we going to install it on our system?
Okay, you are downloading VirtualBox, virtualbox.org. Go to download, select the particular one that your system uses. So if you are using a Windows, you will download the Windows VirtualBox. If you are using a Linux, you know that means your primary OS. So once you are done installing it, then you have to download an operating system. Either ISO, but over is preferable. So when you download over, that's what you will now import to your virtual box, and that operating system would set up and you can use it from your virtual box. Is that
Okay.
clarified now?
Yes, but how can we know if like it's kind of like our system capacity?
At least you have to have, I think most of you should be using at least 4 GB in your laptop now. So once you have 4 GB, you can run a virtual machine. 3 GB, 4 GB, you can run a virtual machine. 4 GB at least is okay. But I think most of you should be using 4 GB also. All right. So,
Yeah, I will check. Thank you, sir.
Victoria.
Okay, I wanted to comment on something. When I used to use a 4 GB system, that stuff hanged my system like mad. Oh.
Okay.
Okay. So I had to like get another device and I had to upgrade to 8 gig RAM.
All right.
All
So
right.
which
So which
VM in
VM in
particular?
particular? Okay, I was using Oracle VirtualBox
I
and
mean,
Kali Linux.
okay, Kali.
Okay, Kali
Kali Linux
Kali
is a
Linux is
heavy
a
file.
heavy file. Okay, no
Kali
wonder.
Linux
Kali
is
Linux is
over
over
8
8
point something
something
GB.
GB.
Just the
Just the
file is there. Kali Linux is over 8.8 GB. It should be 8 GB. That even because the over file is 8 GB. So please, if you are using a lower system, go with Ubuntu. Ubuntu will also give you likely the same thing that Linux will give you. So for now, but you can still try it out. You might get lucky that it will still work. But Kali Linux is a powerful kind of thing like that. So you can go with the Ubuntu. All right, praise.
The Cisco over file, how many is that one? The one that you're going to send us the link to download.
The Ubuntu one is around 3 point something GB, and the Linux is, let me even check it from here. The Linux is, where is my desktop? All right, you can see the Ubuntu is 2.9, almost close to 3 GB, and the Kali Linux is 8.9 GB. So, did I answer your question?
Yes, sir. Yes, sir. Thank you.
So, Stephanie,
Yes, sir. Please, I would like to ask this Kali Linux or Ubuntu, are we downloading it on our virtual machine?
no, you're not downloading it on your virtual machine. Is what enables your virtual machine to be is to happen to take place. It makes it as the operating system of the virtual machine, like you are bringing
Okay,
it. So you are not
okay,
downloading it. You need to have a virtual machine before you download something inside the virtual. So you are using your normal system to download them. Then use your virtual box to import them. Now they are not the virtual machines that is will not be existing. So the operating system itself is a virtual machine that is not existing. Is
okay,
that
sir.
clear?
Kind of, sir.
Is that?
Said kind of.
Okay, what I'm saying is this: they are not the virtual machines. Like you are not downloading it. So virtual machine is more like, okay. Let me just try to say this: you are running a Windows operating system in your local system. That's fine. You want another kind of Windows operating system in the same system to work. Maybe you are using Windows 10, you work Windows 11. So what do you simply do? You download Windows 11. But once you install Windows 11, it will actually replace the already thing that you created. So you now use what we call a virtual box to create a VM. That's a virtual machine. A virtual machine is a kind of a computer that is existing virtually. It's not a physical computer. That means you now have a physical computer. That's what virtual machine is. So inside that physical computer that you have, which is a virtual one, you now install an operating system that will run. That is what it simply means.
Okay. Okay, yes, sir. So now understood. Thank you, sir.
Okay. So any other person? Stella, bring it on.
Good evening, sir. Good evening, sir.
Okay. Okay.
Okay, sir, what you're saying is we first of all download the virtual box, and then the operating system will now import the either Ubuntu into the virtual box, right? Is that what you're
Yeah.
saying?
Yeah. Yes.
Yes.
So
Okay.
because once you do the virtual box, it enables you to create a virtual machine. So, but that virtual machine cannot function without an operating system. The same way your system cannot function without an operating system. So, what you are bringing is the operating system that virtual machine will use. So that's simply what we are doing. So the virtual box on itself is enough to create a virtual machine. But a virtual machine is an empty machine. So there is nothing, it's just like you bought a computer, you didn't install any operating system on it. So what we are trying to do is to bring in an operating system that will make that virtual machine function. Is that clear now?
Okay, yes, sir. Thank you, sir.
Okay. So is there any more question? Is there any person that still have more question? You can. Okay. Oma Lua Susanna. Oma Layo. Sorry.
Omalayo.
Okay.
Now I want to ask that adding Linux that is said in 8.9 gig. Is it the RAM or the
The file itself, the size of the file, that's what I'm the file size, that's what I'm saying is 8.9. It doesn't have any.
Right side.
No, it doesn't have anything to do with the RAM. It doesn't have anything to do with the RAM.
Thank you, sir.
That's true. I think there are some people who are going to have, I think from my class so far, I noticed there are people who are going to be having issues of Microsoft, C++, this thing. You have such an issue, just simply enter that thing and download it and download that thing. It will enable your virtual box to work perfectly well. So if you see something of that nature, please just download that particular thing. Error it is pointing out for you. Then there are also people who their system, the manufacturers of the system will stop virtualization. Like they don't want you to do, because virtualization is the technology that enables this virtual machine to take place. So there are systems that will shut it down. So they didn't open it. They will say no virtualization. So there is a way through which you also go to your command prompt. You know where your system starts, you can be able to change some certain things. When you press F9 for some system, for some other system, you press F11 so that you can be able to go and change some core settings of your operating systems and be able to enable virtualization in it. So whichever case it is, if you have any concerns on that, drop it in the group hours, maybe send a kind of video that will guide you through so that you will not step by step, so that you will not be able to blow it up. So that's on that. Those are the common issues that you see. One of them will tell you to download some other application to edit, and then the other one will tell you that your system doesn't support virtualization. That means the manufacturer didn't on the virtualization. You have to go and on it. So is that clear? So can we proceed if that's so? Can I get a thumbs up? If not, can somebody still bring up their questions? So so that's all on that. That should be the kind of activity I wanted us to do. And you can see there is a major role that operating systems play in our day-to-day. And this is because it enables systems to function. It dictates what system can be able to do. And it controls all the affairs the system have to pass through. And that is the beauty of whatever that we are trying to achieve with operating system. So there is one thing with regards to this operating system. We have what we call the Linux operating system as the core focus of one of the operating system. We don't really want to be talking about anything that has to do with Windows, but we'll exercise more thing on Linux. So when I say Linux, just bear in mind that I'm talking about Kali Linux, Ubuntu, all those Linux distributions, they are part of Linux. So they are part of Linux. So do not actually think about it in one way that Linux. So there are distributions of Linux, as I mentioned. So whether you are using Ubuntu, you are using Kali Linux, you are using Parrot is another, you are using CentOS. So all those things are Linux. They are all part of the command across them. Remain what system. So why is the focus on Linux operating system? Because those are the kind of operating system that enables or supports the command line activities, which are the core way which we execute the most cybersecurity principles and cybersecurity functions that will be applied during the course of protecting our system. So that's why Linux is on the map, because with command line operating system like Linux, we can be able to achieve more things than we can with a other operating kind of system. So one other thing that you should know that this Linux we are talking about is an open source. That means you can change the core infrastructure codes that we are used to develop this Linux. You can change them. You can put them the same way I just said that the over file I'm sending you, that Cisco Cisco on their efforts did some kind of improvement on the already existing open source operating system so as to enable more things to be done pertaining to cybersecurity. So they did a kind of thing, installations and so many things in between. All right, Bola. You can speak up.
Yes, sir. Thank you, sir. I'm so sorry for disturbing, because my question is actually not really related to what you're talking about, but it just came to my mind. So I wanted to ask that when you talk about networking, like, do you need much knowledge of networking in cybersecurity? I mean the practical aspect now, not just the theoretical part, like
Hmm.
the aspect of using cables, configuring and all of that. Do you need a lot of it in cybersecurity? Saying that we're talking about these tools like Linux and all of that. So like where when and when will networking come in security? I don't really get my question.
Yes. All right. From the standpoint of what I'm trying to define, if we have followed us through the course of our journey, is we have network, we have systems. That's why we are even treating operating system, and we have data. So, but everything a person is looking at is to get your data. So the network is what enables system to communicate, and data can exist in either 3 or 4 forms. We have data in use, data stored, data on transit, and I think there's also one other one that I'm missing. So these are the major ones: data on transit, data stored, data in use. So when we say data is in use, the same way most of us are clicking on our systems now, doing so many things, typing in our system and every other thing. So those data you are doing, what you are doing is data in use. I get what I'm saying. Data on transit is maybe you have gone to the internet. So once there's a network that provides the mechanism for data to be on transit, data cannot be on transit unless a network exists. So when you all your Bluetooth and you are trying to send something, you is already a data on transit. So network is an essential part of what you'll be doing as a cybersecurity. As though you might not know the core infrastructures, but it will make you a better security specialist if you know the core network infrastructures. Because many of you will be functioning in the cloud. So you might not get to see all this physical cabling or do all those things. Many of you will be cloud security specialists. You just have to do with access management and all those firewalls and everything. You might not have a physical interface with devices. But many of you will be working in organizations where there are data centers, where devices, routers exist. People have to connect through cable. You must surely know something pertaining to it. But whichever case it is, it makes you a better person, a better security specialist when you know how network functions. Because you are probably, your primary concern is to protect data that is on what? Both data at rest or data stored, or data that is on transit, or data that is in use. So why we are learning operating system is because these are most of the data that will be in what? Use. I get. So network, those ones, it's okay for you to know the grand thing about what it is. Like at least the way we have offered the basic foundation. So when they are saying something on IP address, you already know what they are talking about. When they are saying something on network address, you already know what they are. That's why I took my time, because I know when the other person will be taking over, he's launching straight to core practical of what it means to read a log, what it means to conduct an audit, what it means to use the mmap tool. So when they are telling you that port 25, because I've taught port 25, you already know what they are saying about. So when they say UDP, this network was UDP, you already know what it means. Are you with me, Bola? Did I clear you?
Yes, sir. Thank you, sir.
Okay. So back to what we are saying. So I said the primary concern we'll be getting to is Linux because it's one command line, and it was kind of developed with regards to security, cybersecurity, as it actually powers a lot of devices online. And if you're able to know how the Linux function, we can be able to know how most of other operating systems that also took its form from its functions as well, and will be in a better position to protect the systems that use this operating world system, that use this operating system. So that's why we will be using this. All right, so we'll have to move forward. If you are still with me on this journey, can I get a thumbs up? If not, can you raise up your hands to express your concern? All right, thank you. So what does Linux architecture look like? What does the Linux architecture look like? The Linux architecture is quite a little bit different or has something more when it comes to the general operating system. There are more things you have to consider when we talk about the Linux operating system. So, or the architecture. So when we say architecture, it's like how the build up of something, how something was brought together in order to make it to achieve its objectives. So we often talk about the user and we talk about the applications as the first tier of architectures. So there has to be a user, there has to be somebody that is trying to make or issue a command, get something, make a request, and it does that through what we call an application. So that is the Linux architecture way of functioning. So when we know how these things function, when we know the surrounding build-up of this operating system, we can be able to be in a better position to avert any form of threats that will be coming to them. So we can even be in a better position to know when an intruder has already gotten a hold on our system, because there are many things that we will start noticing that are unusual because we already know how these systems work. So from the standpoint of a user making a request or a command, and there means that have to exist one or multiple kind of users. The same way as we are seeing when I was deploying that, when I was trying to open up that VM, that Ubuntu virtual machine, or a virtual machine that was using an Ubuntu OS. You saw that there were three logins, one for a cybersecurity analyst, the other one for a cyber ops person, and the other one for a security engineer. So each one means that there are multiple kind of users in a particular Linux operating system. So you can use a particular operating system and have different users. And those different users will have different files that they can be able to operate on or use. So that is the beauty of Linux operating system. It gives us the ability that multiple users can be able to utilize this particular system that is in question. Then when these users want to make a request, they use what we call an application. And these applications are installed. They have to be installed. But they are not installed just the same way we just see anyway. We just go to Windows. We just try to do those installation. They are what we call package managers. Package managers is what enables us to install these applications that enable users to be able to carry out one task or the other. Are you all with me on this? If that's so, can I get thumbs up? If not, can somebody raise up their hands to express their concern? I'm so sorry that this topic we are discussing is a critical one, and I think if you don't know it, we will struggle when we'll be doing a hands-on practice system in our next part. So, apart from the user trying to make a request through the application, this application, once that request has been made, there is something we call the shell, which is a command line interface, which enables us to communicate with the core infrastructure of the Linux, which is known as the kernel. So once a user makes a request through an application, a shell, which is a command line interface, takes that word command. It is the interface. It draws all those things that we are able to try to make through an application. It uses a command line expressively to communicate it to the word kernel. But before it communicates it to the kernel, it kind of has to reach out to what we call the file system hierarchy standard, where the files, the data are organized in a Linux system. So these files or data will be able to provide all the resources that this user is trying to interact with. So a minute, please. Okay, so as I was saying, from the standpoint of a user trying to make a command, they will utilize what we call an application. And that application doesn't just have to act alone, it has to pass through what we call the shell, which is the command line I'm saying that kind of allows us to communicate our intent in the way the core operating system, which is the kernel, the heart of the bit of everything we have to work with. So that thing is what we call the shell. And this shell alongside we also point to this kernel, the file system. What is file system? If you are trying to be able to uh, use a particular file, maybe a user is saying, open this document for me. So the shell, we have to also trace where this particular file is located on a system, so that once it is passing out the command of the user who has made a command through the application, it is still kind of telling the kernel where this file that is requesting for in order to do what? In order to make a decision about who is located. So once it passes this thing to the kernel is more like the brain, is more like the heartbeat of this operating system, which will now be able to send it to the hardware to do what it's supposed to do. So the standpoint of there are more things when we try to communicate, unlike the Windows that we are saying that you just have to, the user have to use an application, then the application goes to the operating system, and the operating system will go to the, what is it called? We go to the hardware. But here there are more things whereby the architecture of a Linux have to function with to achieve the very purpose for which we are using it. So it goes from a user using an application, and this application translated through the shell, which are command line interface, and this thing locating the particular files or the things that we want to do or the places we want to store our files or the action that we want to take. These are all part of the file system hierarchy standard. Then the kernel is the one that does the arithmetic kind of thing and sends it to the hardware, which actually executes the main thing that we want to do. So when we want to do something, the hardware is the kind of, when we say the RAM will tell us something, the CPU will tell us something, and all those things. Those are the hardware. So the kernel is the kind of the directive that gives the hardware what, after taking everything that it wants to obtain from the user, by the virtue of the shell, the file system, it takes it in and gives it to the hardware. So the hardware will now be able to read in zeros and ones and understand, and have to translate back to the kernel, and the kernel will be able to tell the shell, even point it to the particular place where this data or file, based on the file system hierarchy standard, the shell will now have to take it back to the application, and the application will not be able to show it to the user. So you see the flow, that it takes more things to understand every other thing that will be happening for a Linux to give us what we want, a Linux operating system to give us or do what we ask. Are you all on the same page on this? If that's so, can I get a thumbs up? If not, can I see somebody express their concern? Just one person is following. I just got one thumbs up. Why is everybody mad? Are you not following? You just pick up already. We are all good for question and answer. All right. So that being said, so there are various kind of Linux distributions. There are various kind of Linux distributions that we have. The same way you have an ice cream, and there are various flavors of ice cream, but the main thing is ice cream. So there are Chisom, all right.
Good evening, sir. Please, I'm sorry, I was disconnected from the call, so during the last slide, I didn't get everything you said. I don't know.
Hello?
Can you hear me?
Yeah.
Hello, sir.
Hello?
Can you hear me now?
Yeah, I can hear you.
I said, I'm sorry, I was disconnected from the call some moments ago. So the last slide, I didn't get anything you said there. I don't know if you can repeat. Please, I'm sorry.
All right. Okay. All right. Okay. All right. Okay. Okay. I know the problem. All right, you guys want me to tell stories. All right, so here is it. Let's get to this. Let's get to this. So take the Linux operating system as an effort for people who are practicing in a particular area, like you that is practicing cybersecurity. So due to that, the systems that we use understand commands. And when they understand that these systems use commands to work, many other people, this is the initial thing that was happening. People have to learn commands. People have to learn how the system works. So many people decided to bring out what we call the Windows, so that people will not have to crack their brain trying to learn one command or the other. So what a potential user have to do is to do what? Is to use the application, click on something, and whatever that thing is doing on the hood, it doesn't concern them. So far they will get what is happening. But it is not just enough for you to be that kind of person, because now you are helping an ID user who is just knowledgeable about how graphical user interface works. That means click and that. He doesn't know what commands powers those things that they are clicking and dragging. So that is what Linux is all about, trying to know the commands, those things that we click, what it actually means in when we write those commands to a computer, as it used to always be. So we want to know when we write these commands, what this is taking up the abilities that we are trying to solve a problem by doing Windows. Now we want to know what makes this thing work. At the background, what is making this thing to work? When we press A, what kind of command is being issued? How is it issued? So that's what we are doing. We want to know the workload that we produce Windows, and somebody have to click an application and the operating system will do everything inside of it and just get back to the person. We want to know what makes this operating system what it is. That is simply our effort on what? Linux. Because if we know it, we will now be able to better protect the user beyond what they are seeing. That is not happening on the hood. That's within the operating system workers. We now know what is happening, and we can be better able to support and protect their data in those systems. Are you all with me on this? If that's so, can I get a thumbs up? All right. So let's move on. So now I was saying something on the Linux architecture. When I say Linux architecture, I'm simply saying what what brings everything we are doing in Linux. Simply, when we say something has an architecture, take it this way: that what is it called? That your house, what makes your house what it is, or what makes your parlor what it is because of there is a what? There is a television, there is a what? There is a fan, there are pictures, there are chairs. All those things are the things that make up, they are the makeup of your sitting room. The same way when we say Linux architecture, we are talking about the makeup, what makes Linux what it is. What makes Linux what it is? What actually surrounds the Linux? What, when we break these things down, those are the compartment of what the entire Linux is and how it functions. What makes those Linux function the way they function? So just say architecture as makeup of something. So see architecture as a compartment, a combination of something that gave rise to that particular thing. So when we disintegrate those things, we'll now be able to treat each individual component as what they do, with regards to what they do. And I say one of the Linux architecture is the user, you, who is trying to make a request. That's you, who is trying to make a request. But you cannot make any request as a user without utilizing a what? Application. So that application is what enables you to make a request. So if you want to type a document, right? You use a Microsoft Word or use a Google Docs. So you are the first architecture of a Linux, because if you don't type anything, the Linux thing will not do anything. So you are the first architecture of a Linux operation as the user. You are the person that needs a request or makes a request. And these users can be as many as possible. Why do I say it's as many as possible? The same way most of you in your Windows operating system, you have ability to have a guest user, and you have an ability to have viewers. You can create multiple users of your system. When somebody has to log in, they will just click on the particular person that wants to log in, enter their username and password. The same thing also goes with the Linux system. There are multiple, there are various kinds of users. So if anyone wants to log in, they will just click on their particular username and enter their password. So every file they are using is just peculiar to them. But all the whole files is in the Linux system. But due to the person that is using that file is the actual user, it will only have access to the files they created and the files that are peculiar to them based on they are the users of that particular user. So the file, any file that user creates is only peculiar to them. The other user that is using the same system will not see those files because that file is just peculiar to them. Are you all with me based on the user? Are you all with me based on the user? If you are with me, can I get a thumbs up? If you don't understand anything, as we are flowing this way, if you don't understand, just quickly say up so that it will not be sounding that technical. So we'll move at this pace. It doesn't matter to me. All right, if we move at this pace. So after the user, that is the person who is trying to get one information or the other, they have to use an application. So that application is still part of the Linux architecture. It's still part of everything that happens in a. So without an application, the request cannot be turned in. The request cannot be processed. So it's the application that enables the user to start its first interaction with the Linux operating system. So having known that application enables us to do one thing or the other is still part of the what? Part of the Linux architecture. And these applications, you are able to install them by what we call a package manager. So package manager is what enables you to install, uninstall an application, and also manage an application that is existing in a Linux operating system. So the same way you go to your Windows, you install them, and you uninstall an application. That is what a package manager does for us. It helps us to install, uninstall, and manage a particular application. Like if we want to update an application, we'll use that package manager. So that package manager itself is also like an application that manages other applications on a Linux operating system. So applications are programs that enable the users to carry out one task or the other in the operating system. Are we all convinced on that? Okay. Okay, so I came into the shell. The shell is another component of this architecture we are talking about. The shell is that command line aspect of it, where we now enter in those commands, where we now enter in those key things that we are doing with the operating system, where we get it involved. So if, for instance, we are using, what is it called? Most of you use Microsoft Word, but in Linux, that is what we call Nano. Nano is the text editor for use. So for us to be able to do this, we will use a shell. A shell offers us the interface. So we will now know, since those application is existing, we will now type in something like nano, which means we are using this application to open a document like this, or we are using this application to create a document like this. So every of these things that you are doing have to be entered into the command line. That is, which is the shell, which gives you ability to enter whatever that you want to do in a Linux system. You have to enter it as command. What gives you that interface is what we call the word shell. Are you all with me on this? Are you all with me on this? So the grass is getting cold. So let me show what is it called again? I don't know if my VM is still open. Is it open? Sorry. I want to show you what is it called again? Okay, my VM is not still open. My VM is not open. So all right. So let's assume you already know command prompt. Eh? This is an instance of what a shell looks like. But if you are there when I open that particular one, the Ubuntu I was showing you a terminal. So this is where we are all expected to key in whatever we are doing as a user. So it helps us to communicate with the kernel, which is the heartbeat of the Linux operating system. So whatever command you want to do, if we want to use an application, we would still type out the application here. For instance, the application we want to use is Nano. And Nano enables us to edit any text in a document. So what I will do is to type in Nano and then tell it file.txt. I'm telling to open file.txt. So nano file.txt. So the application is the Nano, which we are using. And this file is the file we are using. So the place we are entering this command is simply called the shell. So where you enter your command to issue out something you want to be done is what we call the word shell. The application is what enables you to do those things. But where you enter them is where you call the word shell. So that is invariably what I wanted to say. Then I know that another thing you will start asking about is, let me reshare my screen to my slide. Okay. Another thing you want to ask now is the file hierarchy system. Okay. Sorry. It's a file hierarchy system. I don't know if I share my screen and reshare it to not allow me to reshare that particular slide. So sorry. So it's a file hierarchy system. I'm still here. I'm trying to share my screen with regards to that. So it's a file hierarchy system. What does the file hierarchy system does for us? The file hierarchy system, let me simply explain what that is. File hierarchy system, everything that exists on a Linux operating system exists as files. Everything existing on the Linux operating system is existing as file. So what is file? It tells us the location of things that we are trying to locate. It tells us, sorry, the location of the things we are trying to make use of. Okay, let me get to that so that I'll be able to keep our attention on what I'm trying to say. So when we want to use an application, we will still have to enter that application we are using into the shell, because shell enables us to write out those commands. So if I want to use an application that is called Microsoft Word, I will type out in the shell, Microsoft Word is the application I want to use. Use Microsoft Word and open this file for me. So, but it's not just enough for you to open a file. That file is located somewhere, and that is where the file system hierarchy standard so comes in, because it helps to keep track of where every file will be needing either to issue a command or instruction is stored in. So the file hierarchy system organizes those data and files in the Linux. So when we are trying to use Word and open a document, the file hierarchy system is what tells us as part of the Linux architecture where this file is located, so that when the shell we are entering this command, use Microsoft Word and open this particular file, the file system is helping us to locate that exact file. The shell is passing the whole thing down to the what? Kernel. And the kernel is the one that processes, gives the required thing, memory, and then interprets the information to the hardware. And the hardware executes the what? Information. So take it this way, in a simplest way. If you are a user, you want to open a Word document, you use an application, and that application is existing as a command. So it's not this one you say, go and open Word. So Word is existing as a command. So that word in Linux, for instance, is something like nano. So I want to open a document as a user. I've known the application to open that document with. So I will go and type what? Nano. But it's not just enough. Nano has to open or work with some certain things. It has to work with a file. So I will not do what? I will not type out the file name, because what? The file system hierarchy standard will tell me where this file is located. So I will point to Nano, the application, where this file is particularly located. So if the file is located inside a folder that is in another folder, so when I'm typing in my command, I will tell Nano, go to this folder that is located inside this folder and open this file for me. So you are seeing that when we are entering our command in the shell, the file system is also enabling us to specify what we are actually doing when we are entering out our what? Command in the shell. Then once this thing is done, the kernel takes that message or the things that we have typed out in the shell and interprets it and relates it to the hardware. The hardware is the thing that acts upon those things, such as the CPU, the central processing unit, will be the one to do the arithmetic calculations and everything we are trying to do. And then once it's done, it sends it back to the kernel. The kernel also does what it knows how best to do, interprets those kind of information and help us to better utilize it and sends it back to the what? Shell. So the shell now what? Sends it back to the what? Application in question. Because you use the shell to type out the application, it will automatically display for us in the shell. So the shell is the major thing that is standing between us and the what? And the kernel. So the major thing there is supposed to be the user, the shell, the kernel, and the hardware. But why the file system and the application have to come to be is that you will use the applications to issue out command in the shell, and you will also use the file system to able to locate the particular thing you want to do when it comes to processing your information. Is that clear? If that's clear, can I get a thumbs up? Is it still sounding technical? Well, I saw something on the comment. I said, yeah, I understand why the whole thing. So let me rest. Is it still sounding technical?
Yes, I just I need technical.
It's still sounding
Yes,
technical.
yes,
All right,
yes, sir.
you don't have to do this thing on
I don't
nitty
even know the
gritty.
question to ask again.
Okay, just calm down. I think there should be an image on this. All right, I didn't put that image. Okay. Okay, so do you know what will happen? All right. So you know why it's sounding technical or it's still looking
Why?
like it's technical? Is because we have not entered, we are not showing you with the things that we are meant to do with those things. Eh? I've not
Okay,
started
okay,
showing you. I think so once we get to the practical aspect of it, I will show you this is the shell. This is the shell. I'll now show you
oh,
this is the application that we are using. And the application name is, so the way you use Word and you click on it, it opens. In Linux, we type that application as a command. So we'll say nano. So we'll say Word. Use Word and open this document. How many of you have tried Windows and you tell Windows, open this document with this particular application? If you have tried that before, that is the same concept we are using when we come to Linux. We will be able to tell the Linux operating system what application will you use to do one thing or the other. So if you wanted to use some other application over some other application, we'll tell you use this application. So if you want to carry out network analysis, and we have so many tools installed, you will still tell you which tool to use on, and then which file is meant to do what. For instance, let me say, if you want to scan a virus in your system, and you have SmartDAV, what other virus? Norton, is it Norton? Yes, I think Norton. Yeah, Norton. So I think Norton is it a VPN? Sorry, VPN. I think we have SmartDAV. Which other this thing do you use as antivirus? That's the one that I popularly know. So whichever one, then you want to scan a particular file for ahead. This is an instance that will enable me to do what I want to do. So you have various antivirus in your system, and you want to use SmartDAV to scan a particular file. When you enter and open your shell, because your shell is what helps you to type out that command, you will tell your shell, this is the application I want to use over this. So you tell your shell, SmartDAV is the application I want to use. And what do you want? Since you already know SmartDAV is using for scanning, it will also ask you, which file do you want to scan, or which folder do you want to scan? You will say, use SmartDAV to scan this particular file. When you are specifying that file, what you are doing is utilizing the file hierarchy system. You are telling the system which exact file it will scan for you. And once you enter, press enter, the command line goes to the what? It goes to the command line instruction you have entered, specifying the application and the particular file you want that application to act on or to do something on. It will send that thing immediately to the kernel, and the kernel will do the whole thing with regards to interpretation. We do the whole thing in terms to giving it the considerations and making it understandable to the hardware, even to the point of converting it to zeros and ones. It will bring it to the hardware. The hardware will now do that thing that you want it to do, start scanning the whole thing. So once the hardware is done, it will take it back to the kernel, and the kernel will take it back to the shell. You will now see the output of everything you are doing on the shell. So the shell is the primary thing that you'll be using. The applications and the file is the kind of way of trying to tell the shell by virtue of command what to use and what it will do on a particular thing. So it will use a particular application to do something to a particular file. So that is why the file hierarchy system and the applications are major architecture, because you have to tell it, if you want to scan a particular thing, tell it the application to use to do the scanning and which thing that it is scanning. If you want to scan your whole system, you will still specify scan my C drive. It will start scanning that particular drive. So the thing I'm trying to bring your knowledge to is that it should be this way of trying to a user using the shell, entering commands of the application that is trying to use to carry out a particular instruction on a file, and then that thing will translate back to a the kernel, and the kernel will do the whole thing to the take it to the hardware that does the whole thing, and then the user gets back every information it has requested for on the shell. So the shell is what enables you to write the command line, but you cannot write the command line without specifying what you are trying to do, either with an application or on a file. So whichever case it might be, this is just a kind of thing I wanted to explain with regards to that. Are we all on the same page? I know it's going to be but once you start practical, you all will see what I'm saying. I will start showing you every passes of this thing. But you'll not be seeing the underhood thing, or you'll just see the shell doing its thing, doing the command and bringing it. So the main thing you should know most times is how the file hierarchy system works, how to be able to specify the file you want something to act on, then how to be able to key in commands, and then that's it. Key in commands, specify the file that you are trying to do something in, and then get back your output with the shell. So the shell is primarily what you'll be working on, So if that thing requires an application to do, maybe it's not every time you use Word document. Is it every time that you use every other thing, applications on your system? It's not every time that you use that. So whichever one you are using, you will specify what you want it to do, the application is doing, and what it is doing for that particular thing. So invariably, I think we shouldn't continue at this point. I get to the exhaustion point of everyone. I get that. So, all right, so that we'll relax and then kind of come. So when we round it up, we'll be able to do our practicals by tomorrow. These are the three things I'll be using to explain all those things that we'll be doing, these three lab activities on those. So I think that is all for now. So that you take it up and hang it here or for the moment. So we'll still be doing a touchdown by Thursday to start showing you how to communicate with the command line interface, and then possibly round up on this theoretical aspect of it so that you will start seeing this thing practically. And then I think some of your questions will reduce. So I've already taken 24 minutes of your time, more than expected. So is there any question? You can still address it. If not, I think your assessment is to be able to, for those that want to do it, go over and install the, what is it called? Go and install your virtual machines and then get the best out of it. So let's continue the next class and get ready for your practicals. But we'll be doing it with something everybody will be seeing. But at your own leisure, you practice with your local system. All right, praise.
Okay,
Go
sir.
ahead.
What I wanted to say is, please don't forget to share the link of the Cisco over file on the Telegram group for us.
All right, I will do that. Thank you very much.
Okay, sir. Thank you.
Okay, so is there any other business? Bola, is that the same thing that you wanted to say?
Yes, I wanted to say the same thing, sir. Thank you.
All right, no problem. So I think we are in for a whole lot of things. Just go and prepare your mind, get yourself ready for your local systems, and then. But though I'll still do everything on a cloud-based system, so everybody will see it. But it just means so that you can practice on your own, get yourself ready, and then see you by next class, where we will be able to get a review and continue, and then be able to do one or two practicals to reinforce what we have actually learned. So I think that's all for now. All right, do have a nice time and enjoy the remaining part of the week. Okay,
Thank you, sir.
thank you. Okay, stop the recording.